Good evening to one and all present here. About a college. SA Engineering College, an autonomous institution, was established by the Nadu Educational and Charitable Trust in the year 1998-99 with the overall experience of 22 years now. SA Engineering College is approved by AICTE and affiliated to Anna University Chennai. Our college is well equipped with state-of-art world-class laboratories, central library, department libraries, workshops and research labs. We are certified with NAAC and National Board of Accreditations (NBA). Our college offers 10 UG programs and 6 PG programs. SA Engineering College maintains high standards of education by providing a wide array of world-class academic facilities, employing highly qualified and experienced faculty members, and creating an ambience of conducting a high-quality education. On behalf of our college management, I would like to welcome Mr. Saran T and Ms. Kirtana B, final year students, to show their expertise in IoT based home automation and smart specs using Arduino Nano. Now, I'll hand over the session to them.
Saran, you can start now.
Thank you, sir. Good evening, everyone. Today is the fifth day of Excelis 10, and in today's video, we are going to share about the mini project I did in my sixth semester, which is IoT-based home automation using Google Assistant. And by the end of the video, I'm going to show the live demo about how this project is going to work. So let's get started. This is the abstract of this project. There are so many words that you may not be familiar about, but by the end of the video you're gonna have clarity about all these things like Node MCU and the IoT platform that we used in this project, link application and the FTTT website. So I'm gonna just say the abstract of the project. First, I have to connect my Blink Node MCU with the Blink application. So after connecting the Node MCU with the Blink application, so I have to chain Blink application and the Google Assistant. So now this is the complex part. Blink application is developed by a different developer, and the other hand, the Google Assistant is also developed by a different developer. So we are using a website called IFTTT, which is a paid website. By using this website, we can able to chain our Blink application to Google Assistant. So after all this process is done, when a voice command is given to a Google Assistant, which is related to our automation project, only then my IFTTT will able to access my Google Cloud and give the information to the Blink application. Blink application is also a IoT platform by which you can able to control the node MCU, which makes your LED to turn on or turn off automatically. So the interaction part consists of what is a microprocessor and what is a microcontroller, and what is a node MCU, and the important source of our project, which is IoT, and the two IoT platform that we use in this project, which is Link application and IFTTT website. So the first thing we're gonna study about is a microprocessor. So a microprocessor is like a mixie. Okay, so just like Mixi do three jobs, it will fetch the information and it will decode the information and then it will execute. Just like a Mixi, if you put onions in it, and it will grind the onion and will give you the onion paste. Okay, that's how the microprocessor is going to work. So how my microprocessor is going to different from microcontroller is that the microprocessor is just only a CPU, but whereas my microcontroller contains of CPU, memory unit, and IO devices. So by that, how it is different. So if I gave a input to my microcontroller, so it can able to store the input and can able to produce the output whenever it is needed. It's not like, yeah, it's not like, yeah, give output, uh, give input and get output. So it can able to produce output like whenever it is needed. So even in microprocessor, you can able to add a memory. So by interface a external bus using RAM, ROM, and other peripherals. And about node MCU, so there are many microcontrollers available in the market like Arduino Nano, etc. But no MCU comes with an inbuilt Wi-Fi module, which makes IoT projects very very simple. For example, if I did the same project with let's say Arduino I have to buy a separate Wi-Fi module. In the end, I have to buy two components instead of one, which can lead to bigger circuit, higher power consumption, and high cost. So, being an electronic engineer, we always try to reduce the size of the circuit, not to increase it. So, always, uh, choose your components so that you will reduce the size of the circuit, not increase it. And now comes the main source of our project, which is IoT. So IoT is nothing but we can able to communicate with your electronic devices wirelessly from any part of the world with the help of internet. So that is what is given in this slide with the some technical words. So the Internet of Things refers to a system of interrelated internet connected objects that are able to connect and transfer data over a wireless network without human intervention. So we are using two IoT platforms in this project, which is Blink application and the IFTTT website. So yes, first we are going to see about Blink application. So Blink application is an IoT platform available in both iOS and Android devices, which allows the user to control and monitor the hardware project by programming the hardware board with specific Blink key number with proper internet connectivity. So in this project, Blink application is used to create virtual switch to control the LED. So about the second IoT platform we are using in this project, IFTTT. So we are using Google Assistant to send the voice instruction, right? But how it is possible for my Node MCU to get the instruction? I given Google Assistant. That is where IFTTT comes. IFTTT is an IoT platform that can able to access our Google Cloud when the program instruction is given by the user. Then IFTTT passes the information to the link application. Since IFTTT is to connect two or more different application or devices created by different developers in order to trigger our automation. And also IFTTT will give a feedback response to the user instruction. So the name itself, derive it's a programming conditional statement. If this, then that. So for example, if user say turn on the blue light, IFTTT gets the instruction and pass one to the Blink application. Since on means one and send a feedback response to Google Assistant saying turning on blue light. Yeah, just give me 2 minutes.
Saran,
Yes, sir.
your screen is not your screen is not visible, man.
So now is it visible?
Yes.
Okay.
Keep your PowerPoint presentation in full screen mode.
Yeah, it is in full screen mode.
Okay, proceed.
So yes, IFTTT. So for example, if a user say turn on the blue light, IFTTT gets the instruction and pass one to the blink application. Since one on means one, right? And send the feedback response to the Google Assistant saying turning on blue light. So that is why you are using IFTTT in our project. And yeah, so this is the block diagram of the product. Since I have explained like everything about the Blink application, IFTTT, and Node MCU, I think you may have a clear idea about the flow of this block diagram. So I will explain once again. If users say turn on the blue light in Google Assistant, IFTTT activates and get the value 1. Since on means 1 and pass it to the Blink application where we created a virtual switch. When one is passed to Blink application, switch will be on, and since Node MCU is connected to the Blink application to IoT, blue light will be on. So yeah, this is what I just explained. The Node MCU is connected with Blink application. Blink application is connected to Google Assistant via IFTTT website. So after the process is done, when user give a voice command in Google Assistant, which is related to home automation project, the IFTTT will not access every voice command we give in Google Assistant. Only particular voice command is given. Then only the IFTTT will access our Google Cloud. Uh, So yes, after accessing the Google Cloud, IFTTT gives the information to the Blink application. Since our Node MCU is connected with the Blink application, so by this we can able to control the home appliances. Yeah, this is how the output looks like. So now I will stop sharing the screen and show the live demo. Give me a minute.
Saran, what happened?
Yeah, I'm showing my output. Just give me a 1 minute.
Your PowerPoint is not shown here.
I completed my PowerPoint, so now I'm showing my output.
Now you are showing your.
Project output.
Okay.
So I hope my screen is visible. So is everything covered? Yeah. So is my board and okay, okay. So yeah, this is how it works. Here's what I found. Turn on the blue light. Blue lights on. So yeah, now you see when I say turn on the blue light, my IFTTT activates and pass the value to the Blink application, and at the same time it gives me a response saying like blue lights on, and also my Node MCU gets the value and the light will be on. So this is how it works. I hope it's very clear. So that's it. Uh, I hope you gain some knowledge by this project, by my presentation. So thank you so much.
Okay, thank you, Sharon. So, Keetana, you have to start you. Right. Keep it in full screen mode, ma.
1 minute, sir. Is it visible? Hello?
Yes, ma.
Okay. Hello, guys. The topic is smart specs using Arduino Nano. I have done this project in my sixth sem. As I am engineer EC student, I am always interested in technologies. So I thought to do a different project like smart specs using Arduino Nano or Arduino Micro. You can do with any Arduinos, but I did with Arduino Nano. So for the people who are wondering what is smart specs, it is just like the smartwatch, but smart specs allows you to experience a virtual reality. So for any product, we need to know the history. I think it's really important to know about the history of any product. So in 2011, the first smart glasses were created by Google, and then the idea was originally originated in 1980s and 1990s. And Google started selling the prototype of the Google Glass to the qualified glass explorers in the US on April 15, 2013 for a limited period for $1,500, which approximately is a 1,11,500 in Indian money. Before I came available to the public on May 15, 2014, it had an integrated 5 megapixel 720p camera. In 2018, Intel announced it launched a set of smart glasses that are designed to appear like the conventional glasses and are display only. Using Retina production, the project was later shut down. It used OS called Google OS. You all might wonder why Google failed. It lacked the clarity of product and the cost was really high. Due to the privacy issues and all, it was really shut down. So now, as it's costly and available easily, it's not available easily. You can make our own smart glasses for educational purpose and experiment. The experience of technology or you can experience the technology. So here we can learn about basic smart glass. Main abstract of the whole project is the smart glasses are wearable devices that display real-time information directly in front of users. It can also perform more complex tasks, run some applications, and support internet connectivity. It is the application of wireless communication which is used to display the notification in front of the eye. This will notify people at their work, during driving, without disturbance from the drivers, even they do not make a sound. It will protect the display on the transparent material and the lighter switch products are not dark so it do not create any disturbances. So you see the main objective of the smart glass is to enhance the wireless communication all over the world and it minimizes the distance between the physical and digital world. It provides the human interaction with the mobile phone with the help of wireless communication without any disturbance. So, as we are speaking, smart glasses are computing devices worn in front of eyes. Their displays move the user's head, which leads to the user seeing the display independently of his or own position and orientation, in which angle they are in. You can see it clearly. The user can interact with the real world and the digital world simultaneously. As I said before, it provides virtual reality. Smart glass fetches the person and allows you to experience virtual reality. The spectacle-based computer to reside directly on your eyes rather than in your pouch or pack. So we use the components Arduino Nano, OLED display, Bluetooth module, mirror and lens, connecting device and battery. So the connections. We use OLED, as I said. Arduino Nano, we all know, is small, complete device and breadboard friendly and is very small that it can be attached to leg of the device. Here the program is coded in Arduino IDE software. We are not familiar with OLED as OLED is just now getting famous. It is an organic light emitting IO device used as a digital display for mobiles, televisions, and also computer monitors. As we speak about Bluetooth module HC05, is the most important product which connect the phone and the device. Bluetooth module establishes the connection between mobile and the audio. We design it in a way in which Bluetooth modules send the data to the Arduino. After that, they establish a connector to the transmission pin and the received pin in. Arduino also are able to receive the data by the receiver pin by connecting with the transmission pin in Arduino. OLED and Bluetooth. And Bluetooth is connected to the Arduino and OLED. So this is a prototype. This is how the device will look like. So we used every component. It looks very small and compact that you can carry anywhere. This is a very simple device. You can also charge, and this is the final look of a project. So this is you can attach any specs in this device. So I will play the video. So how the output will be displayed. Is my presentation visible? Is my presentation visible?
Yes, my your presentation is visible.
Okay. I'm playing a video. Is it visible?
Yeah.
Okay. So this is the complete device. We have wrapped and it is the device. We display the output, the blue light. It is a OLED inside the device and it reflects back to the mirror and the mirror from the mirror we can view the output from the focal lens where we attach when we attach the specs it will be easily viewed without any disturbance. So this is how the basic smart specs works. Okay. So this is how we attach the specs to the device. It's compatible. So closer view of the specs output. So you might wonder what are the advantages. It's small in size, as we said, easy to wear and use, sensitive, responsible to the presence of people. No need to carry mobile phones in hand always. It's really tough. Wherever you go, it's really necessary to carry your mobiles, but if you have a smart specs with you, it's not need for the mobile phones all the time in your hand. And the maintenance will be very easy. And applications. Used as reminders, used while traveling to get routes. You can attach the GPS device to it and so you can get routes while traveling. It is a very useful technology for all kinds of handicapped disabled people by assisting them by the sound when you connect with the headset or something. It can be used as a virtual reality, some modifications, as I said earlier. By attaching camera, we could also able to capture images and videos like a frame or something like that. So thank you. I will play the video again so that you get a clarification how it is.
Kirtana,
Hi, sir.
is your session over?
Um, yes, sir.
Participants, do you have any doubts from this topic? If you have any doubts, uh, you can post your doubts in the comment boxes. Okay. So no more doubts from participants. We will move to a vote of thanks.
For attending the session. And also, I'd like to thank Mr. Saran T and Miss Kirtana B for sharing their time and knowledge with us. Thank you all very much. That's the end of the stream.